We use a vertical line test to decide a graph is a function or not. We could say every time when I draw a vertical line, it's only one intersection. So this is the function. Same thing in a 2y equals x third power, only one intersection. Every time I draw any vertical line, it's only one intersection. We will use a horizontal line test to decide whether a function is a one-to-one function. We already know these two graphs are functions, but which one is a one-to-one function? Let's draw a horizontal line. For this horizontal line, I have two intersections. Then this is a not one-to-one function. When I draw any horizontal line, then I only get one intersection. So y equals x third power is a one-to-one function. And this y equals x squared is not one-to-one function. Why one-to-one function is important? Because only one-to-one function has an inverse function. So let's check these three graphs. This is y equals sine x. This is y equals cosine x. This is y equals tangent x. We want to create an inverse function for these three trig functions. But when we draw this horizontal line, you could see it's not a one-to-one function. For cosine x, the same thing. For tangent x, it's not one-to-one function. Therefore, people restrict the domain of a trig function to create an inverse function. For y equals sine x, they cut the domain from negative pi over 2 to pi over 2. Only use this part. For cosine x, they cut the domain from 0 to pi. For tangent x, we will restrict the domain from negative pi over 2 to pi over 2. You could see when the domain is restricted like this, then the highlighted part of the graph is a one-to-one function. So they have an inverse function. Now let's go to inverse sine x. Draw and highlight the portion of between negative pi over 2 and pi over 2 of the graph y equals sine x. 0, 0, 1, 0, negative 1, then 0 again. Let's highlight. Let's fill out this table. Negative pi over 2 sine x equals negative 1, 0, 0, pi over 2, 1. Now let's graph y equals arc sine x. Since for inverse functions, their domain and range are switched. Therefore, the domain of y equals sine x is the range of y equals inverse sine x. The range of y equals sine x is the domain of y equals inverse sine x. Negative 1, negative pi over 2. 0, 0, then 1 pi over 2. Let's sketch the graph like this. Now let's fill out the table. Domain for y equals sin x is all real numbers. Range is between -1 and 1. For inverse function, domain is between -1 and 1. Range is between negative pi over 2 to pi over 2. Zero, 1. Then go to 0. -1. 0. +1. Keep going the pattern. Highlight the portion of the graph between 0 and pi. Let's fill out this table. 0, 1, pi over 2, 0, pi, -1. For this inverse of cosine x, let's make the domain and range of cosine x switched so that we can get the table for inverse cosine x. Now let's sketch the graph. 1, 0, 0 pi over 2, -1 pi. This is the graph for y equals inverse cosine x. Now let's fill out this table. Domain for cosine x is from -infinity to infinity, all real numbers. Range is between -1 and 1. For inverse cosine function, the domain is between -1 and 1. Range is between 0 and pi. Draw and highlight the portion of from -pi over 2 to pi over 2 of the graph y equals tangent x. Vertical asymptote line at x equals pi over 2, x equals -pi over 2, x equals 3 pi over 2. Then get 0, 0, pi over 4, 1, -pi over 4, -1. Then you sketch the graph like this. In order to get the inverse of tangent x, we need to restrict the domain from -pi over 2 to pi over 2. Let's highlight this portion of the graph. 0, 0, -pi over 4, -1, pi over 4, +1. We have a vertical asymptote line at x equals -pi over 2 and x equals pi over 2. Let's fill out this table for inverse tangent x. Domain of tangent x change into range of inverse tangent x. The range of tangent x will be changed into domain of inverse tangent x. -1, 0, 1, -pi over 4, 0, +pi over 4. For vertical asymptote line of the graph y equals tangent x will be changed into horizontal asymptote line for the graph of y equals inverse tangent x. Y equals negative pi over 2 and y equals pi over 2. Now let's sketch the graph of y equals inverse tangent x. Draw the horizontal asymptote line first. 0, 0. Negative 1, negative pi over 4. Positive 1, positive pi over 4. Now let's sketch the graph like this. Let's fill out the table below. Domain for y equals tangent x is not equal to pi over 2 plus k pi. K is integers. Range is from negative infinity to infinity. For inverse tangent x, domain is all real numbers. Range is from negative pi over 2 to pi over 2. As we know, f of x and its inverse function are symmetric about the line y equals x. The following three pictures show that three trig functions and their inverse trig functions are symmetric about y equals x. Label the angle negative pi over 2, 0, pi over 2, pi. Then inverse cosine will cover the first and second quadrants. Inverse sine will cover the first and fourth quadrants. The pattern for special angles in the first quadrant, pi over n. The fourth quadrant, negative pi over n. Second quadrant, n minus 1 pi over n. For tangent, let's remember this way. Inverse tangent will cover the first and fourth quadrant. Negative pi over 2, 0, pi over 2. Please remember these two diagrams so that you can evaluate any inverse trig function.